Hello, everyone. Welcome back to the AAS YouTube channel. And this is part of our new series. This is the AAS Journal Data Series. And I'm very happy to have lead Mubdi Rahman with us today. Hey, Mubdi, how you doing?
I'm doing well, thank you. How about you?
Let's see. It is October 20th, 2021 when we're shooting this. Fall has finally arrived in Phoenix.
Oh, nice.
So our temperatures are down a wee bit. The humidity is back down to single digit. And so this means all the Canadians are coming into Arizona as snowbirds.
Avoiding our crazy winters up here.
Yeah, so we do get the annual flux of Canadians coming and going. So it's all good. It's all great.
You just need to charge them, make sure they bring down a good selection of maple syrup, charge them, keep it before a little token.
Yeah, so what's your preference here? Do you like light or dark amber?
I'm a dark amber.
You're a dark amber.
I am very much. I like the mapley. Light is like sugar water, right? You want that maple flavor.
I shall have to remember that. Very cool. Very cool. I really like that eye chart over your Sun, Sirius, Orion, Cygnus, and then your camera lens blurs me out. It's not my vision.
A little bit. It eventually, yeah. So I mean, clearly the camera's not 20/20 vision, but it eventually goes down to the cosmic microwave background.
Very good. Where'd you get that? Where did you get that?
I actually made it. It was just something that I saw something similar to it actually at the Portrait Gallery in Washington D.C. years ago, where they had like these, essentially these eye charts or these Snellen charts. I learned that they're called that for each of the presidential terms. For like major events that happened, and I'm like, hey, I could do something like that for astronomy, and so that's where that idea came from.
That's very cool. I like that a lot.
Yeah,
And that's related to some data. So we're going to be covering a data aspect today. So what are we going to cover today, Mubdi?
So today we're going to be talking a lot about coding tools that you should be using as an astronomer. So basically, these are things that will make your life better and easier, and will have you thanking yourself for, future you will be thanking current you that you started using some of these tools because of all the time and all the headache that you've saved.
There you go. Indeed. So let's go ahead and get into it. And I think you've got a presentation here, and we're gonna.
That's right. Just a couple of.
Encouraging people to do experiments to improve their workflows.
That's right. Can you see? Just making sure.
Yes, it is looking good. And
perfect.
Coding tools you should be using as an astronomer. And that's a awesome color opening slide.
Wonderful. Well, thank you. Well, let's just start a little bit about, I think it's a natural thing to, especially as somebody who's in a postdoc or in a PhD program, when you're getting started, you will it's easy to veer into one of two different ways. One thought is you get started and you start working on something and you do the exact same thing until you're done. Right, like so you take up code that and do the exact same way that your supervisor has done it and their supervisor had done it, right down to the point where they're punching punch cards from back in the 60s and 70s, and you do it the exact same way, and you just concentrate on that. And that's one extreme of the end. That's very natural, right? Once you get something started,
sure.
You'll want to finish it that way. The other extreme can be that, hey, you see all of these new cool tools that you might be able to use and might be able to make your astronomy better and your research, better. But you get caught up in this, seeing all the new flashy things. Exactly.
Flavor of the month.
That's right, exactly. And that leads you to never actually settling on tools that, you spend more time on the tool than the research that you want to do with it.
Right.
And that's a natural cautionary tale. I've certainly run into that before myself as well, where it's like, oh, there's this new shiny thing that could make my life better. Wow. And then I spend like 3 extra months doing something that only should have taken a month doing, right? It's a natural, so
there's a happy middle in there somewhere.
Exactly, right. And one of the things that I'll just start with is, the mantra I take to this is that the best tools are the ones that disappear into the background when you're working.
Yeah.
right? If you have something that you actively are thinking about and thinking about how to tweak it, that can be fun and that can be great to play around with in a great sort of side project. But that's not the same thing as something that's being efficient, right? Like if you think about
Yeah.
things that you no longer really stress out too much about in terms of how you use it, right? Like smartphones are a good example of this, where smartphones have sort of appeared in our pockets and we use them all the time without thinking about the fact that 10 years ago that was a super uncommon thing, right? People like maybe a couple people had Blackberries here and there, but it wasn't a super common thing for people to use it.
Blackberries.
But that's one of those things that it's just kind of faded into the background of how we live our lives and how we do our work now.
Yeah, and there's also there's a time component to that too. So yeah, there's initially a learning curve with these things, and so if you keep using the tool and it's useful, it will eventually disappear into that background. So let me give you an example. So so I'm an Emaxer when I get in the terminal. And yeah, Emacs is a learning curve on learning the keystrokes to make it do things. But after a while, those keystrokes you don't even think about them. And in fact, if somebody asked me how to do something, I would have to actually think, what keystrokes am I actually hitting? Because it's just automatic to me at this point.
Sure.
It's whoop, away it goes. Yep.
Yeah, no, and like I'm sure like my supervisors got me onto Emacs early on, and I definitely like have to remember the Control X before the control thing when I tell somebody to do something. But that's a good example of a tool that, because people have used it and because it's so well developed, that steep learning curve was completely worth it, right? It wasn't going to stop somewhere where it started being completely useless. And not to ignite new flame wars here, but people feel the same way about Vim or VI or things like that.
Exactly.
Yeah, and so, I mean, the thing I think I would leave it at is use the right tool for yourself, right? Like use the right tool for the right job that works for you. Right. If it works for you, then it doesn't matter what other people are doing.
That's the best.
Right. Exactly. That's right. So this is a good mantra to keep in mind in terms of, some of the best tools basically are ones that they do that job for you. Other things that I would throw in here as just things to think about in terms of when you want to, use a new tool or develop a new tool included in your workflow, is think about, is it too new, right? Sometimes, things are experimental. A good example of this that a bunch of my friends were burned by years ago was Google had sort of this productivity networking scheme. Do you remember called Google Wave?
Oh yeah.
Yeah, so people jumped on board and they were like, hey, this was going to be a great way of, getting a lot of my work into sort of this cloud-based system that I could take anywhere with me. And they invested a lot of time, and understandably, right? This sounds, it was really promising, but it was too new and didn't end up getting the user base to support it.
The end state sounded good, but
but at the end of the day, they at some point, because it wasn't picking up, it wasn't used. So there's a natural way or expectation to think of using things that have some user base, that people have already worked at the kinks of. There are definitely going to be people who really want to jump on things the cutting edge, right? Like a good example of this is the people who bought their first Mac OS like M1 chips, right? There are people who are there who are astronomers who are actively working for our community that are figuring out, does IRAF work, or how do I make Python compile correctly, or things like that.
I'm in that category. I have.
Oh, you're okay. So you run into some of those, some of those things, but that is, but go into that with an open mind, right? Like go in that with, your eyes clear that is what you're doing, that you are being an early, adopter, and that's.
And in my case, it was an experimental machine. I was not ready to port my full workflow over to it. It was okay. Does this work? Can I compile this? How does that go? And eventually, it probably will become one of my regular machines, but for now it's still in the, well, not everything works exactly like I need it to. So, but yeah, you go in with an open, okay, I'm going to invest time in this because hopefully it pays off in the end. So
yes,
it's the early adopter syndrome.
Exactly. And there's a great, like, we are, as a community, we should be super thankful for early adopters. They're the ones who run into some of those problems and get them sorted out before the rest of the community can move, jump on board. But recognizing that that's what people are doing, right? And if you have a paper that you need to get out at the end of the month, maybe this is not the month to try to jump over to a new laptop with a completely new system, right? This is, so doing those balances for yourself. But I'm going to go through a couple of tools that, especially knowing, one of the things that we do in astronomy is that we are coding, right? Like the way that we analyze data, the way that we, deal with data as a whole is through a computer typically and through some sort of code mechanism. One of the things that we have the ability to lean on is the rest of the world that uses computers, right? We are a very small fraction of the people who are building software and dealing with software and developing software. And so one of the things that we can do is make use of the fact that there are literally millions of people out there working on new tools that we can use to make our astronomy simpler and better and easier.
Cool.
So I'll talk a little bit, I'll go through some of the ones that I think are incredibly useful, starting with one that I think a lot of people are using, but just wanted to go through and talk a little bit about, and that's version control, right? So I think, Frank, I'm assuming you use Git.
I have used, let me go a little more general. So right there it says version control.
Right.
And I have used many version control systems over the years. Git happens to be the latest, most popular one, but I'm also under no illusion that it's going to be the last version control system I ever use, but it is certainly a popular one at this point. Yeah.
So I'm sure you've, CVS and SVN and
yes.
Mercurial. For those of you who were developing Enzo, for instance, or working with Enzo back throughout the mid 2000s, Mercurial was one that we're very familiar with. But I'd like, just more generally, there's just this notion of version control, right? The idea that it changes a little bit the way you develop, but in a massively better way, right? So just for the basics, version control is a system where if you have some code, you can save an individual version, and then if you add to it, you can save that separate next version, but the original code that you had is still there. It still exists. You can figure out, you can go back to it if there's a problem with your new code. And you can actually share it. You can have other people work on the same code. And so it's a bit of a mind shift or a paradigm shift in terms of the way you set up how you code. But the minute you do it, all of the benefits of it are great. And so Git being one of the bigger ones right now, just there's this entire environment of tools and great things that you can do to compare previous versions and figure out when something broke, if something broke, keeping different branches. All of this stuff is super useful and incredible, that we should be using it right there.
Right. And just, as a comparative purpose, Git is a very complicated tool. It has a lot of stuff that one could use. And most people I know have, used maybe a dozen, maybe 2 dozen active Git controls. That's all you really need to know to get what you need done. But it has hundreds of things you could do with it if you were so interested in doing so with it. But yeah.
And I'm sure those 5 or 6 commands, the people who are using it, they probably forget that they're even doing it, right? Like it's so natural when you save a new change to just, do a git commit or git push or,
You just named 2 of the most common ones.
Exactly. That's right. And it's just, you'll forget that you're using it, but you'll be thankful that you are.
Right. And which goes back to the point, it's so useful after a while, you'll forget even what the command is. It's, what do I do?
Exactly. which is really fun for teaching somebody, because then you have to I know this.
What it is, what is that command? Yeah.
But one of the things I did want to point out, because the vast majority of us are academics working at working at academic institutions,
Mm-hmm.
so universities, there are tons of free goodies related to Git and GitHub specifically. So GitHub being, one of the cloud repositories or one of the cloud systems that you can use Git repositories with. But there's lots of free goodies for academics that you can just sign up with your university email address and get. So for instance, one of the things that you can get just through education.github.com is a free domain name. Right, they will give you, I believe name.com sponsors a free domain name for every academic who chooses to do that. So
Cool.
definitely sign up and get those goodies.
Yeah, very cool.
So the next thing I'm going to throw in here is a better terminal program. A lot of us, started doing research and started coding, and we had one option of a terminal program. Some of us even went, further back, and the only thing that was on a computer was the terminal, right? But we're in a day and age where we can do a lot more than that. And a couple of the things that I'd like to point out, I'll show a couple of examples of terminal programs that you could use and are downloadable and free to use. But some of the things that will change your life when it comes to how you deal with your computer on the command line are, for instance, tabs, right? Tabbed terminals make your life, just that much better, especially if you do anything related to remote machines, if you're going and using SSH or trying to connect to some big national or international cluster, which a lot of us, especially those of us who are working on big data sets or people who are working on simulations will often do. You will probably want 7 or 8 different windows open with different, connected to different machines at different places, transferring data. So tabs are something that really do change your life, and good terminal programs deal with them the same way that your web browser does. Do you remember a time when web browsers only had one web page open per window?
Unfortunately, I do.
as do I. And I actually resisted moving over to tabs. I thought they were this thing that was going to die out, and that some new.
Enormously useful.
Exactly, and that's dramatically changed our ability. And it's really has dramatically changed our ability to compare. For instance, comparing things. That is a good example of something where you can certainly do it in your head. You can go to one web page, take a look at some value or some file name, go to a different web page, and remember what you saw on that last one, and see whether it's not right. But there's just so much better unless you have to do it in your head if they're both on the screen at the same time.
Yes.
So with that, the other thing that a good terminal program, especially a good modern terminal program, does has side-by-side panes or up and down panes where you can break on screen. You can have 2 different terminals that are right next to each other, and especially if you're transferring files, this is just night and day, right? If you don't know what the name of the file is on one system and you need to transfer it, that will just be building up so much rage when you get the file name slightly wrong.
Absolutely, cut and paste from one to the other. That's
exactly
fantastic. And you could do the same thing. What you used to do is put up 2 different terminal windows, and you would put it up, but that takes up a lot of real estate, and it's just not as convenient. And so tabbing is all in one window. It's super convenient.
Yeah, and especially if it builds on a lot of the hotkeys that you just have built into your memory, right? Control tab is just something that I believe most people know to change, or command tab on Macs is to change a tab. And the more you can have those things in common, that you'll forget that you're doing it.
Yep.
So a couple examples of terminal programs that do this. So I'm a Windows user, and so on Windows Terminal, completely open source, completely free. You can get it from the Windows Store, and it does all that tabbing. It does all that, all of the the painting. It's very easy to switch between things. One of the things that I've actually set up that has changed my life greatly, and I know you can do this on other terminal programs as well, is that I actually have the ability to just open up an IPython window. Right, so so instead of opening up a bash or just the normal command line, I can quickly open up an IPython window, do my conversion from kiloparsecs to centimeters or something like that, and then close it off. Right, and that's my calculator essentially. But these are the kinds of things that modern terminal programs can do.
Yep.
Frank, I know you are a Mac user.
I've used Windows before. I can remember things like PTTY and other assorted things.
But What terminal do you use primarily on your Mac at the moment?
These days I'm primarily on the terminal that
Okay.
comes supplied with the Mac down in terminal. I have used iTerm before. I think
Right.
iTerm has a lot of pluses to it.
Mm-hmm.
And those are the two, and I still keep iTerm around. I still keep it
Right.
up. But those are the two my go-tos right now.
Okay. So the one I was going to suggest for the Mac was actually iTerm 2.
Yeah, exactly.
And it is fantastic in terms of,
Yep.
again, has all the tabbing, has all the painting. It also allows you to, very easily customize, macros, for instance. If there's common series of commands that you do often, you can actually program that into your terminal so that just happens, and with
Yes.
a special key code, you can do that.
Yes, it's sort of like the Mac terminal on steroids a bit.
That's right.
You
Yeah.
can
Oh,
do
very
a
much
lot
so.
more with it than you can with just the Apple terminal. That is true. Yep, it's great. Awesome.
So for those of you who are Linux users, don't worry, I have not forgotten you either. One of the ones that's actually a fantastic cross-platform, so it's not limited to Linux, but it's also, you can use it on your Mac system, you can use it on your Windows system,
Right.
is Hyper.
Mhm.
And so this was another one that is, it looks very minimalist, but it gives you the ability to, to tab. It gives you the ability to change, to do all the painting. It gives you the ability to, have macros in there. It's fantastic and worth a download. And all three of these are open source, so
Yep.
you can download them for free to give them a try, see if you like them. If not, move on to the next one. All works.
Cool. Very nice.
All right. So the next one that I'll bring up is a better shell. So this is one that I had to be convinced of.
Okay.
But I know, especially for those of you who are Mac users, Apple has moved over from
Yeah.
Bash to ZSH, and a lot of people are probably rightfully so frustrated, right? Because a lot of your Bash settings aren't converting over. Anytime a big change like this is made, it's frustrating. I understand. I'm with you. Frank, did you run into that when Mac changed over or Apple changed over?
Oh, did I?
Yeah, with the ZSH.
Okay, so as long as you're going there, I am a dyed in the wool TC sheller.
Okay, yes, no, that's fair. That's fair.
I just know how to use it. And again, it goes back, use the tool that makes your workflow seamless. And
Exactly.
yes, I understand TC Shell is older and doesn't have all the bells and whistles. But
Right.
on the other hand, I know it so well that I don't think about how to do something. It just does.
Sure.
And so every time I get a new machine, and you can always have a choice of what your default shell is going to be.
Mhm.
And I just get in the ones. The very first thing I do is I shift it over to TC Shell and I go to
Yeah.
town. Yeah.
No, and that's fantastic. And that, again, speaks to the very much highly to the point of use the right tool for you, right?
Yep.
And so with that background, but
if you are starting out, some
Yep.
of these newer shells, they have a lot more capability and flexibility than some of these previous shells do. So if you're starting out or you just want to try a better shell here, as it says, give them a whirl. Give them a whirl.
Yeah. So the one thing I'll bring up about Z Shell, which is being heavily used outside of astronomy, especially, and a lot of developers are using it, is a lot of different custom prompts have been made for it. A lot of plugins have been made for it that are just based in the shell. So for instance, this is an example of what my Z Shell window looks like. And so in here, for instance, I've got what my Git repo status is right on the shell. I know
Nice.
what the Python environment I'm in right on the shell command. And also tab complete, right? Like the ability to do tab complete has greatly improved in Z Shell, where, for instance, you don't need to actually type in the full path, right? Like, so for instance, if you wanted to do an ls on user bin local or user local bin, you can do /u/l/b, and it'll try to auto complete that for you on a tab.
Yeah,
and so things like this, that the minute you're comfortable with them, you'll forget that you do them, and they'll be annoying when you can't do them.
You can't do it, right. All
Exactly.
Right. Kind of think of it as like an Alexa or a Siri for the command line on the.
Very much so.
Right.
Very much so. So
Yeah,
just as a note, feel free to Google power level 10K if you want a prompt like this. But there's a variety of different shell custom prompts that you can have for Z shell.
Nice. Yep.
All right, the next one that I'll bring up. So this is going to sound like a sacrilege for the vowed Vim and Emacs users, but I'm going to suggest using a better code editor, or a more modern code editor.
Please do. Please do.
And so the one that I end up using, and this is not the only one, is VS Code. So it stands for Visual Studio Code. It is, as of the past few years in the Stack Overflow developer surveys, the most used code editor. One of the interesting things is that it's integrated directly with GitHub. But one of the things I'll bring up about using any of these, and any of the ones that I'll talk about in a second, is they just make your life easier in terms of visually how you see your code, right? So right off the bat, and I'm sure, Emacs, I remember doing a lot of dev with it, and the notion of having the right color for the right keywords and all of the color coding within your code is incredibly useful, right? When knowing that you used import correctly when you're in Python, that you haven't misspelled it, right? That visual cue makes your life easier when you're trying to do something.
Cool.
But when it comes to some of these modern ones, they do things like, for instance, they have built-in bracket matching and bracket coloring, so you can see all of these things just visually, and that makes your life a lot easier when you're trying to debug things.
And let me remind that LaTeX is a code.
Yes, that's right. Yeah, very much so.
And you can't compile because you forgot some curly bracket somewhere.
Oh, entirely, yes. Or some closing of some environment somewhere. Or
so code here is quite general. It need not necessarily be Python or a compiled language like Fortran. Just to remind you, LaTeX, if you're writing your papers that way, is a code. And
yes.
You can get a lot of mileage out of things like making sure you've got bracket completions on both sides. So, how many hours have I spent on LaTeX brackets?
Of course. I feel like it's depressing to try to calculate that.
My goodness.
Yes. Especially if you wanted to get like some fancy font in there.
Yep.
The other thing I'll throw in here is that, remember how we talked about, you want to use the tools that fade into the background?
Yes.
A good code editor really does that, right? Like, I'm sure, Frank, you have in your Emacs, your profile, just so many things that happen automatically for you when you open Emacs.
Yes.
Right? Same thing with all of these modern code editors, or any of these modern code editors. You want to have all of the things that you would normally have to think about just be built into the code editor. So for instance, I actually very rarely go to the command line for Git these days, right?
Okay.
I actually have hotkeys that just do it for me in the code editor and automatically do the commits and the pushes and the messages and all that kind of stuff.
Yes.
Same thing for linting or formatting, which we'll talk about in a second.
Yep.
But you want these things to be invisible, and a code editor is sort of the venue for making these things invisible and automatic for you.
Mm-hmm.
So VS Code is a fantastic one that a lot of people use. Okay. I'd also like to bring on Sublime Text. So this one is was a big one. It's a little declining in terms of the number or the fraction of developers that are using it, but still a very active community. It is, unfortunately, this one is it's a freemium sort of model where you can download it for a trial. They don't ask you to pay, but you should actually buy it eventually under that model. But it's, but again, very extensive plugin selection for basically automating a lot of these things. And the other one that I'll throw in there is Atom. So that's another one that has a lot of these plugins that are built in for you to do things like your Git. It allows you to do your code formatting and code linting, all that kind of stuff right within it, and makes effectively a lot of these processes that you should do when you're coding invisible.
Cool.
All right.
And speaking of linting.
Yes. So
what is linting? What is linting?
So linting
something I have to pick off my clothes because you know,
It is essentially that, but for your code instead.
Yes.
Right. So the idea behind linting is obviously when you compile, like let's say that you're using a language like C or Fortran where you compile, you will run into errors at compile time, right? Like syntax errors will show up at that point.
Yep.
But oftentimes you'll want to run into those problems well in advance because you know if you just look through the code, or if a simple program like a linter looks through the code, it will see these issues or these, these linting, these, brackets that aren't properly closed, for instance. Or in Python, one that's very classic is not mixing up spaces and tabs for your indentation, right? Like how many people have gotten really annoyed because they've copied over, code from some other thing and they use the wrong number, the wrong character.
Or it gets auto replaced, whatever you're cut and paste.
Oh, entirely. Yeah.
Convert the tabs into spaces and all of a sudden it doesn't work.
Yes. Oh, entirely. And then just getting frustrated because either you got to go through manually and won't necessarily tell you, Python will just choke at something. And often one of the things that I find annoying is it doesn't choke at the place where you think it's supposed to.
Right.
Right. It's very frustrating.
What do you mean line 46? Line 46 is perfect.
Exactly. Right. It looks wonderful. But
there's 4 lines up. Right.
So Code Linter helps you get around a lot of those problems before you even get to the point of running or compiling your code.
Yes.
So in Python, PyLint is one of the most common code linters. There's a lot of other ones that definitely explore. But beyond just a lot of the syntax errors, it also helps you keep your code reasonably styled. So let's say that you, for instance, want your code to have a certain style in terms of how you name variables. Right. For instance, one of the typical things that you'll often want to do is you'll want your classes to have uppercase, uppercase first, letters. You want your variables to be a minimum length unless they're, just temporary variables because of the for loop or something like that.
Yeah.
And Code Linter will help you keep those standards, and oftentimes will actually help you replace that. Right. If something isn't right, it'll fix it for you or tell you how to fix it.
Cool. Yep. Very useful.
Incredibly useful. And so again, one of those things that you can have built into your code editor. So VS Code or Emacs or Vim, you can actually have your linter, for instance, run every time you save the file.
Cool. Very nice.
And so just as an example, one of these over here, so this is a linter that in a code set or a code that I'm using or that I was developing, and one of the things that it's looking for instance, is I am importing a specific thing and it knows that I'm not using it. So it's suggesting that I can get rid of it. In fact, I can actually just remove that and it tells me what's going on. And so that's one of the nice things about having these integrated into what your code editor, because it gives you that feedback right where you need it.
Well, it goes in why one want to do that is because you would like your code to be as lean and mean as possible. And if you've got 440 extraneous variables and things brought in that aren't being used, that just adds confusion when somebody else looks at it and is trying to figure out what's going on.
That's right. Yes.
So you want your code to be lean and mean, and this is a way to remove these unnecessary things that aren't even being used.
That's right.
Get rid of them.
That's right.
Yep.
So the next thing related to that is a code formatter.
Yeah.
And so slightly different from code linting, where it tells you about possible problems or style problems. A code formatter does precisely that. It just goes and it formats your code for you. Right? It basically just goes in and says, hey, I know that you've told me that this is your style. You've typed in a bunch of code. I'm now going to make an arbitrary decision of how you want your spaces and your tabs and your inters, and it's going to be consistent all the way through.
Because that's what you need to do.
Exactly. So the most strict of them in Python is something called black.
Okay.
And so I'm going to actually, do you have any guesses as to why it's called black, Frank?
Enforcing number of spaces on a dark terminal?
Not quite. It's actually Henry Ford related.
Really?
Yes. So Henry Ford.
You can get any car you want
as long as it's black. So black is a code formatter that has a very strict way of how it wants your Python code to look.
Okay.
And the nice thing about it is it will always make sure it looks exactly that way, but you have to do it that way. So this sounds like it might be a little constraining initially, but when you realize that this just takes something off of your mind when you code, that you never have to think about it again, and this will do it for you on every save, this will make your life much easier. You never have to think about, did I put the right number of inters on that line, or did I put spaces in between the plus signs, or all that kind of stuff. Right? It's all going to be consistent.
Okay, got it.
So
I do admire the uncompromising part of that.
Yes, that's right. Exactly. It is not going to give you a choice in how your code looks. It knows how your code is supposed to look, and it's going to do that for you. So just as an example, as a very, very, very dumb example here, I, put 2 empty lines, and I just created, import.numpy. On saving, black automatically ran for me, and it automatically, for instance, changed the space. It moved everything up.
Right.
It just shows exactly how that code was supposed to look. And you know what? All of my code looks the exact same. Clean, and I never have to think about it.
Yeah, and there's something to be said for similarity across any code base of any size, right? Formatting from one module to the next is, yep, beautiful.
Or especially if you're trying to find something, right? Something looks like a variable name, or a variable name with a space after it, or variable name with a space in the plus, and then you're trying to search for that exact thing, but oh no, you did two spaces between it, and then suddenly it doesn't work, and yeah. Exactly. And so this is one of the ways of making sure that never happens.
Yeah. That'll save a ton of time.
Oh, entirely. So the next one I'll bring up is Python environments. So this one is, there's a little more of a learning curve to getting these up and running. Frank, do you use Python environments or Conda environments at all?
Conda a little bit, yeah.
So the idea here is, when it comes to, in Python, one of the greatest parts about it, or, many other programming languages are the same way, the power is in all the packages, right? You can download, you can pip install, you can conda install all these packages, and that's what you'll import, and it'll do a ton of things. And a shout out to AstroPy, because it is such a fantastic package that so many people in our community use, and so many people in our community develop.
Yep.
That has provided so much, so much functionality that we don't even need to think about, right? I remember back in the day, just as a aside to just how awesome AstroPy is, I remember having to actually in C deal with how to store coordinates, for instance. Like coordinate transforms on the sky are a pain in the butt. And the fact that I never have to think about that ever again because AstroPy takes care of it for me is wonderful.
Indeed.
But one of the challenges when it comes to all these packages is that each of them are going to be their own independent beast, right? Your NumPy is going to have a version, your AstroPy is going to have a version, your Matplotlib is going to have a version, and things do change over time, right? Certain things can break, bugs can come in, but at certain points, that your code is working, right? That with these versions and things that you have on your computer, it's working, it's great, it's wonderful. What environments allow you to do, either virtual environments in Python or Conda environments, which is actually, you can use in Python, but you can actually use that beyond just Python, is it will create a separate environment with just those versions. What you can do is you can actually save out all of those versions and just those packages, so that, let's say that you're moving to a new computer, you can actually create that exact same environment on something else. Or you have a different project that requires slightly different versions. Right, you can have a different environment that has just those versions. Or you're trying to, distribute your code to somebody else, a collaborator. You can just give them the environment file, and they can set up exactly what you have set up.
Yeah, and this goes a ways also with reproducibility.
Yes,
right.
Very much so.
Right, so if you knew what all the environments were, you could set it up and reproduce it. So this also goes the ways toward, that aspect of sustainability and reproducibility in a code base.
Exactly. Yep. Yeah. And it's one of those things that, so long as you have that environment, the minute, it takes just a few seconds to set up once you know how to set it up. That will then save you in 2 or 3 years when you move over to a different computer or you move over to a different institution and they have their own cluster and things and all that kind of stuff.
Right.
it's yes, it's wonderful for it to be reproducible for the entire community, but being reproducible for yourself
you.
is already a win.
That's right. That's right. It's reproducible for you.
So related to that, this is a little more advanced. I'll only briefly talk about this. Is container systems. So much of the world has moved towards doing computing in containers, right? And what a container is instead of you have all of your operating system installed on your laptop, let's say, and all of your Python or your compiler for C, all of that stuff, all the drivers, everything is on your laptop, and that is how it's doing it. What a container is basically a virtual environment that has its own operating system. And the idea there is more than just the Python packages now, but you can actually have the entire stack right down to the exact Linux versions that you're using or whatever versions you're using saved and like locked in. And so all of that can then be run in anywhere, literally anywhere in the world. So for instance, one of the examples is you can set that up on your laptop and then move that. Let's say that you're doing some sort of analysis with radio data, and radio data is very large, and so you have a very small set that you're trying to make it work with, and then you have it working. What you can then easily do is move that container over to a cluster or a cloud environment, or a lot of big clusters in North America use a Docker adjacent thing called Singularity, which is just another container system that is compatible with Docker. And you can move that exact analysis and the exact file paths and the exact version of everything that you're using over to a much, much larger computer to do this in bulk. Right? That's one of the great things about these kinds of container systems.
Right. And one other point about container systems is they allow you to become, once it's set up, you become operating system agnostic.
Exactly. Yeah.
You set it up on a Windows machine, it will run just as well on a Linux machine or anywhere else. And so, yeah, it's great for portability issues of whatever you're trying to do.
And just like those environments, it'll keep all those versions built in, right? So if you have it frozen into that container, it's going to stay that way, and it's going to run. And that is super helpful when you go back 5 years later and you need your code to be up and running to reproduce a result or to make a plot or something, and you don't know, like, you don't want to try to install all that stuff on your own again.
And you may not even be able to.
Right. Yeah, very much so. Very much so.
So it's super useful for particularly pulling older things that you still need to work or you want to work.
Right. So and speaking of older things that you'll want to work, one of the other aspects that's great about container systems is that it's a shared open environment that a lot of people publish containers for base containers with software that already exists. So for instance, Frank, do you remember in the mid 90s or late 90s, early 2000s, attempting to install IRAF on a new computer?
I was only born in 2010, so no.
Nice.
Yes, I remember IRAF, and I remember yes.
it was difficult, right? It is authentically difficult to try to install.
Painful.
There are people who have done that work for you in a container where you can just say Docker pull and then the name of this container, and suddenly you have an IRAF installation for you. So this is the kind of thing that really gets enabled. So, one of the things that's super common, especially I know for grad students, is when you're getting started, you can easily spend a couple of weeks just getting the software installed on your computer. This is the kind of system that if you get into, I fully admit that there's a learning curve initially.
There is Docker, yes.
But if you get into, it becomes super easy to then just say, hey, I'm going to do a bit of image analysis in IRAF because they're, my supervisor has the IRAF scripts. I'm just going to grab that container and run it there. And then, oh, look, I need the radio data. So I'm going to grab my CASA container and move it over there. Or, and suddenly I also like the X-ray. So I'm going to use my CIAO tools and, from the Chandra tool set and use that. And suddenly all of this stuff is much easier to get up and running quickly. So
go back to the theme, right? After a while, these things will just fade into the background of
That's right.
And that's the best.
So the end goal, I think I would like to sort of leave everyone, land message here I'd love to leave everyone with is try to spend some time upgrading your toolkit. Think of the things that you spend time thinking about, right? When you're trying to do code, obviously what you care about oftentimes is your research result or the data that you're trying to analyze. But there's often a bunch of things that you'll probably be doing to get to that stage where you can think about the science or you can think about the data. Think through what are the tools that might make might make your life easier, right? Might it be something that helps you transfer data quicker or transfer data more seamlessly? Might it be something that tests like the validity of the data that you're looking more easily, right? Whether or not it's actually properly formatted or the FIS file is right. Spend a little time doing that because it can often, sometimes there won't be a good answer, but sometimes there will be, and it will save you a lot of time in the long run.
Indeed. Yep. The little upfront investment can pay off big time on the back end. So totally agree.
So Frank, what's the favorite tool that you end up adopting over time? I know you've talked about Emacs as being one of the ones that has saved you a lot of time and effort in the long run. But are there any other things that over the years you were resistant to, but then picked up and realized it saved you a whole lot of time?
Linters have been useful for sure. As much as I don't like uncompromising anything, things that will, auto format my code according to how I want it formatted. So it saves me from myself.
Yeah.
And tell you how many times I've looked for some variable and looking for an add or something, and did I put 1 or 2 spaces between that add?
Yes.
And you have to look for both, and it's just a horrible waste of time. And if you had, behaved yourself as you said you were going to do, you wouldn't run into this problem. But of course, we're all human. We all just do things, and so having a tool like that, I personally have found to be very useful. Both of those on formatting and linting codes. Yeah. So those are 2 that and I just like to experiment as well. I mean, I don't experiment with every flavor of the month that comes out with everything. Right. I usually will wait until something's got a little traction and then I'll check it out. And if it looks like it might do something, I'll put a little more time into trying to integrate it into the workflow. And not all of them work out. And so it's okay to experiment and spend a little bit of time. And if looks like it's not going to work for you or you don't like it, it's okay to let it go.
Entirely.
But that and the fraction will vary from person to person, but even if you only ended up adapting 10% of what you experiment with, that 10% will save you 100% on the back end on, wow, how did I not live with this tool before?
Yeah. Oh, entirely.
So yeah, sometimes you don't know what you need until you try it. And then you go, oh my gosh, how much time did I spend doing that? My goodness. Yeah. And how about you? What's been some of your personal favorites?
Yeah, so I think one of the ones that a trap that I fall into, and this is something that I just love to throw in as just a warning, is that there tends to be like a lot of sort of almost macho gatekeeping to a lot of computing tools, right? There are people who are like very insistent that if you don't use a command line for this, then you're not truly using it, right? Like in getting away from that gatekeeping, because sometimes there is a very simple thing that you want to do. So one of the things that actually has dramatically changed my life is basically a GUI SCP client or a GUI SFTP client, right? Like because I used to be one of those people that's like, yeah, no, I'm going to do it on this command line. I'm going to XCP / whatever or rsync that. But the amount of time that you spend trying to remember what the exact file path was when you only need one file or you want to get one plot from some remote system and transfer it to your desktop, right? That is not worth versus just opening it up and dragging and dropping, right? There are sometimes that is completely okay. Don't let people gatekeep you into doing something that is just so much harder.
Right. Yeah. If it's not causing you a lot of pain, you must not be using it right. And
that is not the mantra that
exactly
we want people to have, right?
Exactly. That's the mantra. So let me give another example of one that saved me an enormous amount of time. It was technology development. I typically have a small farm of machines for many reasons, backup for this, that, and the other reason. And so I used to spend an enormous amount of time rsyncing between machines, so that if a machine dropped or something happened, that I would have an identical machine over there. And so I used to spend a lot of time doing rsync. And then things, and not to pick any particular one, I'm just saying the one that I use. There are other options out there, but Dropbox changed my life, how I do syncing. I don't even think about it anymore. Right. So, and then change it on one machine, it's automatically changed on another machine at a block file level, not at a file level, at a block level. So it's a lot more friendly on your bandwidth. But yeah, I used to do all kinds of rsync. I probably have to look up how to do an rsync command. Not really, but but that's an example of a technology change that can change your life if you give it a whirl.
I mean, I think similar to that, I'm sure, or potentially right now, you're also probably using something like Time Machine on a lot of your systems, or Windows backup or Windows versions on. All of these things that I remember times when people were insistent that they would build their own rsync code and do that, and then always something breaks like a year down the road, and it stopped doing that.
Guilty.
Yeah, and then you spend like a day or two trying to fix and trying to recover that. And obviously, you only check when you need that backup, right? Because that's when it's happened. So things that are now set and forget that other people are doing are wonderful.
Yeah, indeed, very cool. Well, we've covered a lot of ground today. We covered version controls, we covered terminals, we covered shells, text editors, linters, formatters, environments, containers. We covered a whole bunch of stuff that if you haven't heard of them, now you have. So give it a whirl. And these are just some examples of things that can really improve your workflow and ultimately get to the astronomy that you want to do quicker, easier, and faster.
Yeah, very much so.
Awesome.
Thank you so much for having me, Frank.
Thank you for guiding us through an absolutely wonderful presentation on making one's life easier in astronomy. All right, everyone, that will do, and we'll see you on the next one. Bye-bye.
Bye.